Yesterday we solved equations that were exponentials. Today we're going to solve equations that are logs. Now, yesterday we talked about this property. It says this. An example would be something like this: 2 to the x plus 1. I'm just making this up as I go, and 2 to the 5. How did we do this problem yesterday? So they have the same base, right? So we cross them out, and then we just solve what's left. So we would go like this, and go like this, and we have x plus 1 equals 5, and then we would solve what's left. What if the bases didn't match them? What was the strategy then? Try to make them the same. So didn't we start with the big one? See if the big one can turn into the small one? What if that didn't work though? Yeah, so, well, you can't make the small into the big one, that's possible. But what you could do is try to break down the small one some more, and then see if the big one could break down into what you change the small one into. So that concept was is very similar to what we're going to see today, except today it's going to involve logs. So if you have like the same base, you can cross them out and solve what's left. That's also true if you're working with two logs. So if you notice, there's a log on the left and a log on the right, and they happen to have the same base. If these logs have the same base, you can cross out the logs and then just solve whatever is left. So that's almost the same exact concept as what we talked about yesterday, it's just now it has logs in it. So I noticed in this problem right here, or in these problems, I broke it down into kind of like what they look like. These both have, or not both, well, I guess both. Both problems have two logs in them, one on each side. Now the catch to this is the bases of those logs, they have to match. So just a little bit of review. What is the base of this log right here? 10. That's 10. We figured that out on the first day, that anytime it's blank, it has a base of 10. So we have one log on one side and one log on the other side whose bases match. So we can just cross out the logs and solve what's left. So we have 5x equals 2x plus 9. And then we just subtract 2x. So we have 3x equals 9, and then we just divide by 3. So that means x is equal to 3. And if you want, you can plug it in and make sure it works. 5 times 3 is 15. Log of 15 is a decimal. 2 times 3 is 6. 6 plus 9 is 15. It's the same decimal. So guys, the reason why we're allowed to do this is because of the basis from yesterday. Logs are just exponential problems written a different way. Why don't you guys do the second one for me real quick? I'll give you about 45 seconds. There's no tricks here. Tricks are for kids. Anyone get an answer yet? You get 0? Yeah. Guys, look at this. In order for these things to be the same, right? They would be the same. So, I mean, I don't expect you to be able to see stuff like that. So you should, like, solve it, all that stuff, plus 4x, plus 4x. But the part where I noticed it, because I was kind of doing it in my head, is I have a 10 here and I have a 10 right here. So when you have the 10s, you got to subtract it. That's where you get your x equals 0 from. Okay, now if you think about, remember again, I keep tying this back to yesterday. Remember how I taught this yesterday? We started with like the easy one first, and then I showed you have to like Once they don't match, you have to change them so that they do. That's kind of how I'm going to show you the logs. So the ones I just showed you, those are the easy ones. They're just ready to go. You just cross out and solve. So if you guys turn to the next page, these are the ones where it doesn't really fit what I just taught you. These questions on this page, they only have one log. So we can't cross out the log anymore because it requires one log on each side for us to be able to cross them out. So if you see a problem that only has one log, this is where converting back and forth between the different forms is helpful. So let me just refresh your memory. If I have an exponential function, and it's like, I don't know, how do we do it? Oh, it was b to the x equals y. Do you guys remember the formula to like change it into a log? So this is going to be exactly the same as log of log base b. And then do you remember what we did with these two things? Y. Yeah, all you do is switch these two. So this right here becomes the y, and this one over here becomes the x. That's what we're going to have to do in these problems right here. The one thing, though, is you got to get the log so it's all by itself before you do your conversion. You'll see all of these problems, they all have logs in them. So we're going to be going this way. They have logs, and we're going to change them to exponential so that we can solve them. Again, the catch to this, the log has to be all alone. You can't have anything before or after your logs. So if you look at examples, or this problem 7 right here, it's got the minus 10. We need to get rid of that first. So we're going to add 10 to both sides. So we have log base 3 of n plus 3 equals 0. Now that doesn't mean that your answer is automatically n equals 0 just because the whole thing says it equals 0. You have to go through the conversion. So to convert this now to the other form, the exponential form, this 3 comes straight down and becomes a big one. And then we take these two and we switch them. So the 0 comes up here, and then the n plus 3 goes over here. Now we can solve. 3 to the 0 is 1. And then we just subtract 3 from both sides. So n equals negative 2. And just like in any other problem, you can always type it in the calculator to check to make sure it's right. If I put in a negative 2 right here, you get log base 3 of 1. Anytime you have a log of 1, though, it's 0. So basically, this goes away, and you end up with negative 10 equals 10. Let's do number 8 together. What do I need to do first in number 8? Yeah, we can't have any numbers that are not like, when I say inside the log, I'm talking about this right here. That's inside of that log thing. So the negative 2 is not inside, so I need to get rid of that. So I divide it by negative 2 first. So I have log base 5 of 7x is equal to negative 1. So now that the log is all by itself on one side of the equation, I can convert it to the other form. So we're going to go from log to exponential form. So this 5 comes straight down, and then these two things switch. So I have, let's see, what do I have? 5 to the negative 1 equals 7x. How do you get x by itself? Just divide by 7. So you end up with 1 over 35. If you're wondering how I got that, just type it in the calculator. Put 5 to the negative 1 over 7 is going to be 1 over 35. Mathematically, what happens is the 5 just goes down because it's negative. So then it's 5 times 7. So that's how I got the 35 at the bottom. Yes. Oh, yeah, but the NFD is 1 over 35. Above the 8. Let's see what we got here. Log. Okay. So look at number 9. What do I have to do first in number 9? Got to be real careful with this. This problem. So maybe I should have told you this ahead of time. This entire negative m plus 2, it isn't like this. If it was, it would have had the parentheses. So if there's no parentheses, that means that it's only around this. So if the parentheses aren't there, technically the parentheses are only around the first thing. Yeah, so we have to subtract the 2. If we wanted all of that stuff inside the log, we would have put it all inside of parentheses. So that means the 2 is not in. So we have log negative m equals 2. What's our base? 10. Yeah, it's blank, so it's a 10. So I need to know that because when I convert, this comes down into a regular 10, and then these two things switch. So this is 2 equals negative m. And that's pretty easy. That's 100 equals negative m. So I just have to divide by negative 1. So I get m equals negative 100. So do you guys see how on 10, this time on 10, it does have the parentheses? So they're very explicit when they have the whole thing inside the log. So again, when the parentheses are missing, that means only the first thing is inside the log. So this problem, again, got negative 6, negative 6. So we have log, is that a 3? Log base 3 of x minus 3 equals 4. So I have a single log on one side and it's all by itself, so I can convert it to the other form. So this becomes the 3, and these two things switch. So this becomes the exponent, and then I have x minus 3. Three to the fourth is 81. So I just add 3 to both sides. So x equals 84. So what you need to know about solving equations that have logs in them is there's 2 scenarios. Scenario number 1 is the easy scenario where you have 1 log here and 1 log here. In that case, you just cross out the logs and solve what's left. The other scenario is if you only have 1 log in your problem. If you only have 1 log in your problem, you have to get that log by itself. And then once it's by itself, you have to completely change the form into the exponential form. Because remember, guys, again, day 1, the first thing I try to get you to understand is that logs are just another way of writing exponentials. So it's helpful to be able to switch between the two. So you can see that we can set up easy equations to solve. Let me look at the packet real quick because I don't know what I want to assign. Does anyone have the packet, the homework packet? So let's see, breakpoint 4. We got a lot of time. There's only 12 questions. Let's do it. Do it all. 12 questions. Do it before you leave.